Hello student, this is Pratibha from Chalukya Academy. So today we are going to take the third session of periodic table from 10th ICSE chemistry subject. So in the last session we already discussed that we are going to see these periodic properties of the element like atomic radius, ionization potential, electron affinity, electronegativity, metallic non-metallic character, electropositivity, oxidizing and reducing property, density, melting point and boiling point. Okay, so in the second session we have done atomic radius. So we have seen the definition of atomic radius, that is the distance between the center of nucleus and the outermost shell of the atom. As I told you, this is very important concept because based on the atomic radius you are going to decide the magnitude of the remaining periodic properties in the periodic of the periodic properties in the given periodic table, how they are changing, how their magnitude is changing across the period or down the group. Okay, so again we just have a small recap of atomic radius. That is, what is the atomic radius? It's the distance between the nucleus and the outermost shell of an atom. So you can see here from hydrogen to sodium, number of shells are increasing as well as atomic number also increases. So the net nuclear force of attraction decreases, so atomic size increases. As we go from sodium to aluminum, you can see here number of shells remains same but number of protons increases, so nuclear force of attraction increases as we move from sodium to aluminum. So net nuclear force of attraction on the outermost electron or on the valence electron increases as we move from sodium to aluminum. Okay, so this way the atomic radius is changing, and the factors affecting the atomic radius are the nuclear charge and number of shells. As we already discussed that nuclear charge depends on the number of protons. Greater the number of protons present in the nucleus, greater will be the nuclear charge, and if the nuclear charge will be greater, then atomic size will be smaller. So you can see here the relationship between the nuclear charge or nuclear force of attraction with atomic size or atomic radius, so that is inversely proportional. Inversely proportional means what? As the nuclear charge increases, atomic radius decreases. Okay, so in the last session we have seen this chart, okay, that the trend of atomic size in the periodic table. So here we can see these are the period number, period 1, period 2, period 3 and so on. These are the group 1A, 2A, 3A, 4A, 5A, 6A, 7A and 0 group. As I told you that we are not going to see the properties of 7th period, and in 10th ICSE periodic table, the portion for the 10th ICSE board is you have to learn the elements thoroughly up to period 3. So now across in the periodic table, atomic size decreases across the period. So you can see here how the atomic size decreases as we move from left to right, and as we move down the group, atomic radius increases because number of period number increases means what? Period number denotes what? Number of shells. So as we move down the group, number of shells increases, nuclear charge also increases, but both are not supporting each other, so atomic size here increases. Okay, now on the basis of atomic radius we are going to see the next periodic property, that is ionization potential. Okay, now let's understand what do you mean by ionization potential. Now ionization means what? Ionization means formation of ions. What do you mean by ionization? Ionization means formation of ions, and potential means what? Energy. Potential means what? Energy. So how you can talk about the ionization potential? The energy required to remove or energy required to form the ions. Now dear students, you know how the ions are formed? By loss or gain of electron. So here the definition is given, it is the amount of energy required to remove an electron from the outermost shell of an isolated gaseous atom. Outermost shell means valence electrons. It is this energy is always we are taking for the electrons which are present in the outermost shell, because valence electrons are away from the nucleus, so nuclear force of attraction on the valence electron is less. So dear students, we can only remove or we can only isolate the valence electrons. We cannot remove inner electrons because inner electrons are closer to the nucleus, so nuclear force of attraction on the inner electron is higher, so we cannot provide that much amount of energy to remove the inner electrons. Therefore, the ionization potential energy is always the energy required to remove an electron from the outermost shell of an isolated gaseous atom. Now, here we can see the examples of hydrogen, lithium, sodium. So you can see here, this is the valence electron present in hydrogen, lithium and sodium respectively. So you can see here, as the atomic radius increases, the distance between the nucleus and the outermost electron, that is the valence shell electron, is also increases. So definitely nuclear charge on the valence electron decreases as the atomic radius increases. So if the nuclear charge decreases, that means the nuclear force of attraction on the valence electron decreases over here, so definitely we need a less amount of ionization potential to remove valence electron. Okay, now as I told you, inner electrons are not at all taking part in it because the nuclear force of attraction on the inner electrons is very high, so we cannot provide that much amount of energy to remove the inner electrons. So always ionization potential we always measure on account of what? Valence electrons. Now here you can see, as we move from sodium to aluminum, here atomic radius decreases. So in the magnesium, these are the valence electrons, in aluminum these are the valence electrons. So you can see here the distance between the nucleus and valence electron is decreasing as we move from sodium to aluminum. If this distance between the nucleus and the valence electron decreases, that means nuclear charge on the outermost electron increases. So definitely we need a more amount of energy to remove electrons from the outermost shell. So here we can conclude that, as I told you, that for every periodic properties you first have to think about the atomic radius. So here atomic radius is inversely proportional to nuclear charge. Okay, but nuclear charge is directly proportional to ionization potential, or we can say ionization potential depends on the nuclear charge. So ionization potential is directly proportional to the nuclear charge. So greater the nuclear charge, greater will be the ionization potential. Okay, so we can say here that atomic radius, greater the atomic radius, smaller or lower will be the ionization potential. So here we can see here that the relation between the atomic radius and ionization potential is inversely proportional. Okay, so here we can say that, again we can come to this chart. In the chart itself we are going to write each and every property, how the properties are changing. So here atomic size decreases, so definitely nuclear charge increases across the period. Okay, and if the nuclear charge increases, definitely ionization potential increases across the period. Now in this case we can see that atomic radius increases down the group, so definitely nuclear charge decreases down the group. So as we move from from first period to seventh period, atomic size increases, so definitely the distance between the nucleus and the valence electron increases. So nuclear charge or nuclear force of attraction on the valence electron decreases, so IP also decreases as we move down the group. Okay, so this is all about the ionization potential. So we can see here, if we consider this element and this element, you can compare that the atomic size of the magnesium is greater than the atomic size of phosphorus. So magnesium ionization potential of magnesium is lower than that of phosphorus. Okay, so now we will go to the next periodic property, that is electron affinity. Now in case of electron affinity, we are now electron affinity is related to, or we are mainly talking about a non-metal. Because what do you mean by electron affinity? It is the amount of energy released when an atom in the gaseous state accepts an electron to form an anion. So in this case, non-metals have a tendency to pull the electron. Now in this session we are going to see that why metals have a tendency to lose the electron and why non-metals have a tendency to pull the electrons. Now when I take an example of fluorine and chlorine, okay, so now fluorine has atomic number 7 and chlorine has atomic number 17. So fluorine electronic configuration is 27 and chlorine has electronic configuration 287. Okay, so here I am drawing the atomic structure. So this is 2 electrons and here the 7 electrons. Now chlorine, 2 electrons in the first orbit, 8 electron in the second orbit, and again 7 electrons in the third orbit. Now here you can see that the atomic radius of fluorine is less than the atomic radius of chlorine. So if the atomic radius is less, definitely nuclear charge on the outermost electron is greater, and here the nuclear charge is smaller, due to which what happened here, atomic size of fluorine is greater than the atomic size of fluorine. Now in this case you can see already 9 electrons are there, so electron repulsion are already present in an atom. Similarly in chlorine 17 electrons are there in the nuclear region, so there is already electron repulsion among the 17 electrons. Now you can see here, to complete the octet, fluorine as well as chlorine needs one more electron. So when chlorine or fluorine will accept the electron, one more electron, so what will happen? When the electron is added over here, protons remain same, that 9 protons remain same, that the electrons will increase by 1. Here 17 protons remain same, but when we are adding one more electron, before 70 electrons are there and now 18 electrons. So dear students, you can see here that protons remain same, that is nuclear charge remains same, but electron repulsion will increase, because before gaining the electron, fluorine has 9 electrons and chlorine has 17 electrons, but after gaining the number of electron is increasing, so definitely electron repulsion is increasing, but nuclear force remains same, so definitely the nucleus will find difficulty to keep 10 electrons or 18 electrons within an atom. So what will happen? The atom needs what? Energy, and the atom will get unstable. So definitely to remove the instability or to lower the instability, the atom will lose the energy, will release the energy, and that energy is nothing but what? Electron affinity. Greater the electron repulsion, greater will be the energy released. So in this case, fluorine and chlorine will have a electron affinity. So it is the amount of energy released when an atom in the gaseous atom accepts an electron to form an ion. So when it will accept the electron, it will become what? Fluoride ion, and when it will accept the electron, it will become chloride ion. So this is what we can say here. So as we move from the across the period, what will happen? Nuclear charge increases, okay, ionization potential increases. Now here we can say that electron affinity increases across the period, but here electron affinity decreases across the period. So again, when you are talking about electron affinity, start with the atomic radius. Greater the atomic radius, smaller will be the nuclear charge, and smaller will be the electron repulsion, and therefore electron affinity also lesser. In this case, atomic radius is smaller, so definitely nuclear charge is greater, When the nuclear charge is greater, atomic size gets shrink. When the atomic size gets shrink, electron repulsion increases, so more energy will be released when an electron is accepted by the electron. So electron affinity increases across the period. So this is about the atomic radius and how we are relating ionization potential and electron affinity and nuclear charge with the atomic radius.